Hello CSI135 students. This is just a quick video tutorial review of Chapter 7, the Linux shell, and there's a number of topics we're going to cover in here. I'm briefly going to go ahead and demonstrate a couple of those topics that we've seen. So Chapter 7 starts out with the command line, and it talks about command names and arguments. So when we type in ls, right, that's the name of a command. If you take a look at the man page for ls, you can see that you can list out some options, right? And then it can also take file names as an argument. So one of the options that we've used is ls-l, and this will provide us with a long listing of the files in the current working directory. And again, ls can work with an absolute path name as the argument. So if I wanted to see what was in temp, right? If I wanted to see -lai, right, and L is going to give me a long listing, A is going to show me any hidden files, and I is going to show me the inode number for each file in the given directory. So I think we created dir2 yesterday, as you can see we did, right? Okay, so the key takeaway here is that ls is a command. Okay, it doesn't require any options. Who is a command on the command line that does not require any options. And again, it doesn't require options, but there are options available. And so according to the book, an option is a special kind of argument that you can provide that will change the behavior of the command, or change the default behavior of the command. So if I type in man space who, you can see that you can provide the -a, -b, -d, -h, and so let's do who with the -h and see what that looks like, right? And again, provides the heading, okay, because if I type who by itself, right, we don't get the heading. So it's kind of nice to get the heading. You get the login name, the terminal that they're connected to, the time that they connected to the system, and then usually the IP address or the fully qualified domain name and IP representation of where the individual is connecting from. Alright, so again, if I type who, we can see we have a number of students in our class online right now, B6, B13, B8, right? Okay. So the next thing that Chapter 7 talked about was how the shell processes the command line. And one of the things that you need to be aware of is that the shell can process the command line even if in some cases things are out of order. The cat command was the utility that they used to display this functionality, and this was also part of your lab. So if you were to take a look in your home directory, and maybe you have some files in there, and I'll use hosts, and let me see what's in hosts here. So host just says this is my file, and so then I'll do uptime and put it out to sysup, right? So I have two files, hosts and sysup. So if I was to type in, redirect the output to new file, we'll call it new file 99, and the input is going to come from sysup, and then I type cat, right? Now this command will work even though typically what you would see is you would see cat with sysup, right? And then the output would be going to new file 99. Now we should get an error message here because I have the no clobber variable set, and I certainly do. And so this was something else that Chapter 7 looked at, and that was using the pipe. If I'm absolutely positively sure I want to overwrite that file. So now if I cat new file 99, you can see that all I have is the system uptime inside that file, right? So again, remember that you can, in some instances, put the arguments and the commands out of order, and the entire command will still work. Alright, next it talked about the path variable. And so there are two key ways you can see your path variable. You can echo space $path, and $path is the variable that represents the path that your shell will search in order to find command names that you provided. The other way would be to do, and we're in our home directory, right? So pwd. So if I were to grep path from .bash_profile, and you can see that There's a comment here that there we go, that the path directory is being exported, right? And this is the value of the path directory. Okay? That's another way to see it. And these are variables here. These will expand out to whatever the value of $path is, right? And they've got that defined further up in the .bash_profile file. All right. The next thing that Chapter 7 talked about was standard input and standard output. And again, remember that standard input is typically your keyboard, right? As I'm typing in commands, I'm providing the input, right? And standard output is typically your screen. So one of the examples they give you was the cat command. So if I type in cat and I don't provide any arguments, and then I type in this is cat, you'll notice that all it does is simply concatenate out exactly what I'm typing. Hello, 1, 2, 3, right? And then up, down, left, right. So it just simply concatenates out what I'm typing. So I do Control D to kill that. All right. Then it talked about concatenating multiple files, right? So let's say I want to see what's inside of memo. Oh, I'm sorry, memo's directory. Let's take the same files we were working with earlier. So I'll say new file 99, and then I wanted to see what was in January, and then I wanted to see what was inside of hosts, right? So I could cat all three of those files. Now January is empty, and we know that from our lab, but I get the uptime out of new file 99, and then I get this is my file from hosts, right? So this is one way that you can take multiple files and it'll concatenate them in the order from left to right, and you can even redirect the output into, we'll call it catted file, right? So if I catted file, there you go. So that's how you would concatenate multiple files at one time, and that's even how you redirect, right? Redirect the standard output. Now, there could be occasion when you want to redirect standard input from an existing file. So I could type in cat and then put new file 99, and that will redirect the standard input from the file new file 99 to the cat command. Now, you're probably asking yourself, why would I need to do that when I could just simply type cat new file 99? And that's a good question. You won't always use the less than sign to redirect the standard input, and oftentimes it's not practical to do so. But again, this is so you have an understanding as to how to redirect input on the command line. That's using the less than sign. So I've already mentioned no clobber, and so if we take a look at my .bashrc file, you can see that I have no clobber set, and the -o means to turn no clobber on. So if I type in set -o, I can see a list of every possible option that I could set. All export, brace expand, Emacs, so forth and so on. So we're interested in, so we're interested here in no clobber. And as you can see, no clobber is on. Okay, if you didn't want to set no clobber, and let's walk through this. So if I VI my .bashrc file, and I come down here and I take out the no clobber, and I'm going to save that file. If I type set -o, you're going to see that no clobber, as we would expect, is still on. So what needs to happen here, and typically you don't see this right away in the text, but typically what would happen here is you need to source the .bashrc file again so that that variable, or whatever it is that you have set or unset, gets read. So if I do .bashrc and type enter, and then type set -o, interestingly enough, you're going to notice that it is still on. Now if I were to log off of the system and log back on, let's see if that does it. So I've disconnected, now we're going to reconnect, right? So set -o, aha, so no clobber is off, right? So if I log out and log back in, it would be there. From the command line to turn it on, I could type in set -o no clobber, right? And then if I type set -o, we're going to see that now no clobber is on, right? Now what if I type set +o no clobber, right? And I'll type in set -o, no clobber is off. So interestingly enough, The -O is used to turn the option on, and the +O is used to turn the option off, right? So interesting, because you would intuitively think that the plus sign or the addition sign would be used in the case where you're interested in adding the option to your shell. But here it's just the opposite. Okay, and that is the no clobber command. And again, remember that no clobber prevents us from overwriting an existing file. The next thing in Chapter 7, it talked about pipelines, right? And so the last command is a great command that you can use to work on some pipeline work, okay? And so, because you get a lot of output here with last. So if you were to be presented with a question that said, show me everyone that's logged onto the system, I don't want to see anyone from our class, right? So let's say grep -v CSI135B, right? Because grep, that means with the -v, means give me everything except that pattern. And I'm not interested in anyone who's logged on Thursday, right? So Thursdays I'm not interested in. And I'd like to see that list sorted. And let's see what that looks like. So here we go. Right? A much smaller list of individuals. Right? So now I could even make that pipeline longer. Let's say I'm not interested in seeing anyone from the CSI135G, CSI135G, and I only want to see users from the CSI135E class. Right? So now that's a pretty good pipeline right there. You've got a number of filters, 1, 2, 3, 4 filters, right? And then here it is. It basically distills it down to CSI135E. Now, this is simply for demonstrational purposes, because if you're thinking ahead, right, if I did this, right, grep for CSI135E and then pipe it to sort, well, we get a pretty close listing to what we've already got there. Again, I threw the Thursday in there, so we would have to obviously grep-v for Thursday and then pipe it to sort, and we get an identical list from what we had above. So again, remember, the key takeaway here is that the standard output from the last command becomes the standard input for this grep command. And then whatever the result of this grep command is, the standard output from that command becomes the standard input for this grep command, right? And then finally, the standard output from this grep command, which is run from last to this first grep to this grep, all of that comes through and is then the standard input for the sort command. So let's say that I wanted to check, and we'll make a list of the users who have been logged on Thursday before we strip them out. And I'll call it Thursday users, right? So here we can use the T command. And what the T command says is, I'm going to go ahead and run these commands, but I'm going to run last, I'm going to grep for CSI135E users, and then I'm going to tee it off, right? I'm going to tee off a process that will append the output as it looks right here at this section, or at this point in the pipeline, which is the last command, and then grep on CSI135E. It's going to create a file, but it's also basically forks a process, right? So it creates that file Thursday-users, but then the output not only goes there, the standard output from this file continues down the pipeline, right? Unchanged. So the T command does not change any of the standard output that comes through it on the pipeline. So if I hit enter, you can see we still get the output here, but if I cat Thursday users, we get the exact same output minus the users. Oops, I was going to say, see what that command looked like real quick. Hold on one second. Grep-v thu. Oh, right. So prior to us, yeah, so when we cat it out. So when I do this command here, Thursday is stripped out. I apologize there. Lost my place. Thursday is stripped out, and then if I cat Thursday users, we will see the users who are in here on Thursdays. Okay, so that's a great example of the command line, how you would use a pipeline on the command line, and what the filters are on the command line. The next thing we talked about were jobs, right? And if you've got jobs running, how you can see what the job number is, how you can see the process ID number of the job, right? So I'm going to kick off, we'll do sleep 180, and the sleep command is a great command to use in shell scripts. So sleep does nothing but let the shell sleep. So it's going to wait here for 180 seconds before it completes. Now, I'm not interested in waiting, so I'm going to do Control C. So if I do sleep 180 and I do the ampersand, and remember the ampersand is a special character that will put the sleep job, this first one here, in the background. So if I type PS, you can see that we have a job, right, that's running. The command is sleep on terminal 7. That's the terminal I'm logged into, and here's the process ID 20151. And when we first ran this process and put it in the background, you can see 20151. So let me run sleep 380, or I'll do 280 and then we'll do 380. And again, the ampersand at the end puts each of these jobs into the background. So when I do PS now, you can see we have 3 sleep commands running, all with different process IDs, and you can see the job number is placed right to the left prior to the process ID. So how do I see the jobs? You simply type jobs. So you have job number 1, job number 2, and job number 3. You can see it's sleep 180, 280, and 380. Now, let's say I want to pull one of these jobs into the foreground out of the background. So what I could do is I could type in FG space and then the job number. And as you can see, it's going to pull the sleep 180 command from the background into the foreground. All right, so that is a basic look at job control. All right, so one of the last things that the chapter talked about were some of the file name generation and path name expansion type characteristics of special characters. And this is where we had the files memo, memo1, memo2, memo3. And so let me touch memo1, touch memo2, touch memo3, right? So if I type ls mem question mark, what would you think that that would match? Right? Now the question mark is an interesting special character because it has to match something but can only match one character, right? It can be any character, but it can only match one character, but it has to match one character. So when I hit enter here, we're going to see it's going to give us memo back. It's not going to give us memo 1, memo 2, or memo 3. Hold on one second. ls memo mem. All right, so hold on a second here. So something is not doing what I anticipated. Make sure I'm in the right directory here. Yeah, because those files are not. Oh, yeah, the memo. So apologize. All right, so that did do what it was supposed to do. So real quickly, I had overlooked the fact I have a directory in here with the name of memo, right? So when I typed ls mem question mark, and this is actually a very good example, I typed mem question mark, not only did it list out the memo directory, right? Well, actually, that's exactly what it did. It listed out all the files in the memo directory. So if I cd into memo and do ls, you can see that that's what it listed out. So we'll work from within inside the memo directory there. I apologize for the confusion. Okay, so here are the files that we have. So if I were to type ls mem question mark, what would you think that that would match? And we're going to find out that it only matches memo, because again, the question mark matches one character and one character only, but it has to match something, which is why it doesn't match ME, okay, and why it won't match MEMO1, right? Because this is only going to match one character, and it turns out it's the O. So if I were to touch MEM and run that same command, it still only matches memo, right? So the question mark has to match something. The difference between the question mark and the asterisk, or one of the differences, is if I type ls mem asterisk, Remember that the asterisk will match 0 or more of any character. So in this instance, we are going to get mem, but we're also going to get memo, memo 1, 2, 3, 99, 99999, right? Okay. Now, the question came up in class, well, what if I'm interested in putting, I know it starts with ME followed by 3 characters. Can I use 3 question marks? You certainly can. And as you would expect, remember the question mark matches one and only one character. So it'll match an M followed by an E followed by any 3 characters, but it has to get at least 3 characters, which is why it does not match me and why it does not match mem or memo. It will only match a character string that has 5 characters in it, and memo 1, 2, and 3 fit that fit that description. Okay, the sleep 280 command just finished, so we've been notified. Another part of the job control is that you'll be notified when jobs in the background complete. Okay, so that was the question mark, and we've already talked about the asterisk. So if I were to type in LSMEMO asterisk, would it match MEM or MEMO? And the answer is it'll match MEMO, right? But then it'll match 0 or more of any character after it, as you can see here. The final special characters we talked about were the special characters, the open bracket and the close bracket. Whoops, put a space in there. Open bracket and close bracket. And so how can we use this to our advantage? So if I type LS and I want to see MEM and I want to see memo followed by any single digit, right? So that's how it would be for any single digit. So what we're going to see here is memo 1, memo 2, and memo 3. And like the question mark, the 0 through 9 has to match something. Because you'll notice we don't match just memo, right? We're saying memo followed by a single digit, single numeric character. So what if I wanted to see it followed by 2 numeric characters? Right? I could do 0 through 9, 0 through 9. What about 3 numeric characters? And I think you get the point now, right? And again, oh, and we have job control just finished. Let's run this again. All right, so the 380 seconds is up. So there we go, right? You can do ls memo. Now, what if I wanted to do, I know I want to see files, I think they begin with an M. There's got to be 2 characters, and it can be followed by, let's say, 3 characters here. We'll tee one up with 3 characters. And then a digit followed by anything. What would that match? So let's take a look. It's going to match memo 1, 2, 3, 99, 999, and then with the 4 9s. So we're saying we're going to list out a file that begins with the character M followed by any 3 characters. So in this case, it's going to be EMO followed by a single digit. So 1, 2, 3. So again, it has to match. Up to this point right there, we have to match something, which is why this string in here does not match me or mem or memo, right? Because we're saying it's an M followed by 3 characters, any 3 characters, right? Followed by a digit 0 through 9. And then the asterisk says after this string of M, 3 characters, and a single digit, it can be anything. And here's where we get 99, 999, and 9999. All right. The last thing that was talked about were the shell. The last thing talked about in Chapter 7 were the shell built-ins, right? And there are a number of shell built-ins. If you type in man bash, right? Oops. And I do a /, I look for built-in. It will bring you to a number. Oh, this is options here, arguments. We're looking for the built-in commands. See shell built-in commands below. So we've got to scroll down a little bit here, and there's some shell variables, right? The different types of variables that you can have. All right, some arrays, some expansion, some brace expansion. Let me see, we'll do shell built-in. All right, we're still looking, It's down here. All right. Shell built-in commands. All right, here we go. Unless otherwise noted, each built-in command documented in this section will accept options preceded by a dash, and it accepts dash dash to signify the end of the option. So source, right? And that's one of the things we did when we sourced that .bashrc file, when we did the // .bashrc, right? Alias is a built-in, okay? Background, to move a command into the background. One of the more popular ones is CD, and we'll see that here in a second. So there's the CD. And remember, CD moves us into our home directory, right? And that's a shell built-in. And what that means is that the shell does not have to spawn an extra process in order to run these commands. Where typically, commands that you run like who, the shell's going to spawn a process to do that. So these are built in, so they'll be executed, and again, semantics here, theoretically they'll be executed faster, right? But in terms of whether typing cd space /temp, or if cd was not a built-in, how much quicker it would run, it's really semantics. It will be quicker, but probably not to the human eye. Okay, and there's echo is another one, right? And we can echo out commands, enable. So again, this is how you get to the shell variables. You take a look at the shell built-in, excuse me. You take a look at the command line. All right, and then Chapter 7 wrapped up with the exercises, so make sure that you have completed all of the exercises at the end of Chapter 7, and we'll be going over those on Wednesday night. All right, enjoy the rest of your weekend, and I will see you on Wednesday.